Well, good day, Year 11s. All right, so today's our first lesson looking at compound interest. Now, we've briefly mentioned the fact that compound interest exists a couple of lessons ago, and it was kind of obvious that some more complicated version of interest was going to exist because we've been calling interest so far simple interest. Sort of suggests that there's going to be some kind of complicated interest. And there is. It's called compound interest. Okay. Now, the best way to understand what compound interest is to first compare it with simple interest. Okay. All right. Now, we're going to do exactly that. So here we have a brief example of simple interest. Alice invests $1,000 for 3 years in an account that provides simple interest at a rate of 10% per annum. It's a very generous rate of interest. All right. Now, the thing about simple interest is we know that for each of those 3 years, she will get 10% of the principal, the original amount. So, after the first year, the balance after year one, let me turn on my pen, is going to be the $1,000 plus an extra 10% of $1,000, which is $1,100. Okay? Simple. The balance after 2 years in her account, well, she now has $1,100 plus another 10% of the original 1,000. I emphasize the original 1,000. So she gets a further $100. Okay? So she now has a total of $1,200. All right, so that $1,200 carries over into the next year. So at the end of the third year, Alice will have $1,200 plus 10% of the original $1,000, which is another $100 on top of that $1,200, which is $1,300. So it's growing linearly, isn't it? $1,100, $1,200, $1,300. It's just growing by $100 each year, okay? So that sort of characterizes simple interest. All right then, well, let's take a look at compound interest. So here's our compound interest example, and the wording of the question is exactly the same as the simple interest example, except for one single word. So Alice invests $1,000 for 3 years in an account that provides compound interest at a rate of 10% per annum. So what's the difference? Well, let's take a look. After 1 year, this is how we would calculate Alice's balance. So she starts off with $1,000 and then she earns 10% of that $1,000 interest, okay, which is $100. That gets added onto the 1,000. She now has $1,100. Exactly the same as a simple interest example so far. All right, but on the second line here, the balance after 2 years, here's where you'll start to notice a difference between compound and simple interest. So after 2 years, we will carry forth her balance from the previous year, and then to figure out the balance at the end of the second year, we don't add on 10% of the original amount, we add on 10% of the amount currently in her account. So the amount that she initially invested last year plus the interest that she made last year, which is $1,100. So it's 1,100 plus 10 over 100 at 10% of 1,100, which is $1,210. Okay, so slightly more than in the simple interest example. Now, to find the balance after 3 years, this comes down here, okay? $1,210 plus 10% of $1,210, not 10% of the original 1,000, 10% of the new amount, $1,210, and we get $1,331. And as you can see, that is again slightly higher than the $1,300 in the simple interest case. Okay. So I guess the moral of the story here is if you're offered the exact same, if you're investing this exact same principal over the same period of years, over the same number of years at the same interest rate, except the difference is that one offer you were provided is for simple interest and one offer that you were provided is for compound interest, you would take the compound interest choice because you will earn more money. All right? So that is the difference between simple interest and compound interest. All right, so what I want to do now, just really quickly, is we're going to compare a couple of graphs here. And this is, I expect, what you thought you would see. Here's a graph for simple interest up the top here, okay, right here. For every year that goes past, the amount of your investment, so that's your principal plus your interest, so what your investment is growing to, increases by the same amount. So we get a linear graph. A year goes past, we go up by the same amount of interest. A year goes past, we earn the same amount of interest. A year goes past, we earn the same amount of interest, and so on. Okay, so as I've said here, the amount of the investment, so the total amount of the investment, increases linearly with time. But in the example of compound interest, what we can see, if we just for a moment come back up here, if I do 1,210 minus 1,100, okay, I'm going to get $110. But then if I do $1,331 minus $1,210, I get $110. So in the case of compound interest, year after year, the value of your investment grows by a bigger margin because you're making interest on top of interest on top of interest on top of interest. Okay, so it grows, compound interest grows exponentially. So we get this nice curved graph here. All right. So the amount of your investment increases in a non-linear manner. So, and I've written in brackets, the investment grows faster than for simple interest. All right. So that is the main difference between simple interest and compound interest. All right. Now we have a nice little formula for compound interest. It looks quite different from the formula for simple interest. But here are its components, okay? And let me just read from the top. The future or compounded value of an investment or loan can be determined using the following formula. A equals P bracket 1 plus R over 100, right bracket, all to the power of T. Now, what do these variables represent? Well, A is the future or compounded value of the investment, just the future value of the investment. It's not I, it's not the amount of interest, okay? You can use A to calculate the amount of interest by subtracting the principal from it. But that would be a further step, a step that a lot of people often forget. So A is the future value of the investment. They will sometimes call it the compounded value. P is the principal, the original value. R is the rate of interest per year, per annum. And T is the total number of years. Okay. So let's look at two examples. Okay. Question 1. Bethany invests $8,000 at 8% interest per annum for 3 years with compound interest paid at the end of each year. Find the compounded value of the investment, which means just the final value of the investment, after these 3 years. So what will her $8,000 have grown to after 3 years of compound interest at 8% per annum? So we write down the formula and then we substitute in our values. The principal, the starting amount, the investment, is $8,000. 1 plus the rate of interest, which is 8% over 100, all to the power of the number of years, which is 3. And we find out that her investment, after 3 years of compound interest at 8% per annum will have grown from $8,000 to $10,000, to $10,077.70. All right. Now, her investment grew from this to this, which tells us something about how much interest she would have earned. Okay, so let's read part 2. Find the amount of interest Bethany made over these 3 years. Well, the amount of interest Bethany made in dollars over these 3 years must simply be this value here minus the amount that she invested. The amount that she ended up with, which is A, minus the amount that she invested, which is P. Okay, so we get $10,077.70 minus $8,000. So $2,077.70. All right, now finally, a CAS tutorial. So investing compound interest using a CAS calculator. Now, first let me say, don't stress if you don't have your CAS calculator on you yet. I'm recording this video probably quite a while before you are actually capable of going back to school to collect your CAS calculator. So if that is the case, then don't bother with these CAS calculator questions until we sort out an alternative arrangement. But we're having meetings this afternoon to talk about this sort of thing. If you do have your CAS calculator, there's nothing to stop you, and I would in fact like you to read through this tutorial, okay, follow the tutorial, and then answer any relevant CAS calculator questions relating to this tutorial in the corresponding exercise. But once again, if you don't have your CAS calculator on you, we're in the process of talking about solutions to this problem. One solution is that you download the app, but for this particular function, you would need to pay something like $4 a month, but you can cancel any time. So you might like to just download the app onto your phone for the Casio Casio ClassPad. But that's your choice. Obviously, you might not be able to do that. All right, guys. Thanks for listening, and I'll see you next time.